First, I hate vocabulary and definitions, but you gotta really know what you're talking about. If I have a graph like this, okay, the word relative and local, you'll see both of those on different sheets. And they mean the same thing. And they mean literally what they sound like, as opposed to the words like logarithm and asymptote, okay? Like for instance, local or relative would mean like, suppose that this is the valedictorian at a school in another state, and it's a very small school and there's 10 people per class, okay? As opposed to another person applying for college. They're also the valedictorian of their, but it's like one of those math and science schools that are treacherous, kind of like ranked top in the country, okay? Another thing could be like, I remember my high school, that sounded really sketchy. I was gonna say my high school quarterback. I remember our high school quarterback, he was not my quarterback. Friends with my boyfriend. But anyway, he was great. And we were like, oh my gosh, look at Ken Toller. He's just amazing. And he got a college scholarship and he played quarterback in college. Then he went to the NFL and lasted a year, I think, with the Patriots. Okay? Then there's Tom Brady, who would probably be the absolute max, even though Eli and Peyton Manning are a lot better. But Tom Brady is incredible, okay? So what I mean by that is, do you see locally, I hope Ken doesn't mind me, I doubt he listens to my videos. So locally, we were like, he's the greatest thing. They write newspaper articles about him in Mississippi, like, Ken Toller's awesome. And in Mississippi, a lot of good quarterbacks and football players come from, so it was a big deal. You gotta wait and see what happens when you go somewhere else.
Where did you play in college?
He played on this, which is also a big deal.
Yeah.
If you listen to
so who was your boyfriend? Was your boyfriend a football player?
He was, number 66.
Oh.
I remember. Okay, so I can't remember Tim's number. I'll get a picture of him up here one day. The football team. Okay, so anyway.
Did you wear his jersey to games? Did you wear his varsity jacket?
I'm sure I did for a while.
That's the dream.
Yeah, they had class rings. I don't know, we dated for a long time. But anyway, back to this. I've already told you that story. Back to this. There's another word called absolute. And it means you were the best that ever lived, okay? You were the best that ever came through, and you would be the absolute max. It'd be the GOAT, all right? Now, absolute men, if you're talking about that, you're like, oh my gosh, like I didn't want to make the lowest grade of everybody around, and then you certainly would think, well, I don't want to be the absolute minimum, like the worst grade ever that anybody's ever made, or the worst quarterback ever that anybody's ever had. So a good analogy here is golf, because you want a low score. So you might be an incredible golfer for your team, but there's people like Tiger Woods and legends like Jack Nicklaus.
Phil Mickelson. He's in the commercial with the Enbrel. Yeah, so he's like my joints.
But y'all see what I mean? So you would go, wow, I shot a 70 on the golf course, which I can't. Nor would I want to, unfortunately, but Arnold Palmer, yeah, there's a drink after him.
Yeah.
Anyway, but if you went in the PGA Tour, then all of a sudden you might not have the absolute minimum score, okay? So local means relative to the people that you're around. Local means relative to the people you're around. Relative and local, that just means, look at all of us, I've got the cutest shoes, kind of thing. However, if you came to the Mass Center today, I would not be the absolute max of shoes, because Miss Cece's shoes are better than mine today. So she's the absolute max in shoes today, okay? But I have a pair like it, so you'll see them soon. But y'all see what I mean? Okay, so it means overall, what's the best? Who's the best actress? Who's the best golfer? Who's the best quarterback? Who's the best? So, by the way, relative and local maxes and mins for being the absolute. Do y'all see, if all I see is this part of the graph, I would definitely call that a relative max. Local to everybody there around, that is a relative max, okay? This is also a relative max, but you see, if I know everything about it, that ends up being the absolute maximum. Now, do y'all see a relative minimum here? What about the absolute minimum?
There's none.
There is none, because it just goes down forever. Okay, so all we have there is a relative or local. Those words are interchangeable as you see them. You can use whichever one you want when you're writing a problem. So here, this is a relative min, this is a relative max, and this is a relative min, but it's also the absolute min. By the way I drew this one, it almost looks like that the derivative would be undefined at that little pointy point up there. What do I mean by undefined? What if one direction my slope is 1, and then all of a sudden my slope is -1? Do you see it would create a pointy point? I need to know that. That means the derivative is undefined. It was not a smooth transition. A word I'm going to say that, I'm always going really fast once I get started. I've said before, locally linear. If I zoom in on this part of the graph, do y'all all know that it will actually merge into its tangent line? If I zoom in on it, it'll be like those little bricks, little toothpicks right next to each other. If I zoom in on this, it'll flatten out and look like the line y equals 0, okay? If I zoom in on this part, something like that, I could zoom in forever and I'm going to still have 2 slopes. Do y'all see what I mean? Sometimes even, unbeknownst to you, if you zoom in on enough, the one that's like a bird, okay, the x minus 1 to the 2/3 graph, if you zoom in on this enough, this is all you eventually see. It's actually a vertical tangent there. As these are coming in a negative fashion, they'll really dive deep down into that and it'll become vertical, which is a big deal. I want to know that, okay? So all those things can happen. So our vocabulary, I think, is out of the way, and we'll look at this for all year long. All right, now let's go to number 1. All right, number 1, you have y is equal to, your homework will be on this kind of stuff out of the book. And I'll go ahead and say it, a quiz on related rates. So let's pause and look at the assignment. On Friday.
There's so many things on Friday.
I have an essay and a test.
I can change it to Tuesday.
Yeah. I would honestly rather Tuesday. Thank you.
Okay.
Thank you. Wow.
All right.
Because we don't want to give it to
And by the way, I don't think y'all expected me to be that agreeable about that. A lot of times it's going to be too bad. It's just a quiz. But right now it doesn't even really matter. I just want to have a quiz on related rates before the next test and before we go too far. So I'll change the assignment right now. All right. So homework will remain out of the book. Here's a related rate quiz, and everybody listen, I hope, and we'll have to let Emma know how this works, but I think I spelled it out fine. You can study both related rates worksheets. I barely worked any with you in person, so please see me, tomorrow or Friday or Monday if you want to work on some with me. You can also go and find all those gazillion problems on that live binder site. This time, I've listed the problems so they appear in bold, so you're not worried about things you haven't learned yet, which I'll let slip in sometimes, okay? So can y'all see where they're in bold there?
Yep.
All right, so that quiz will be Tuesday. What will that be? October 29th? Anybody know what Tuesday is?
29.
So I'll also put this on Friday's assignment because you may not want to worry about it till over the weekend or whenever. Okay, so bookwork, and I haven't really put the next test on the calendar, so now that's changed. All right, so you have a quiz on related rates, and you can come with some questions. I'll show you this real quick, Emma. quiz is on Tuesday on related rates.
Okay.
And if you want extra problems to study, it's one of those links again to A Million Problems.
Okay.
And I'll put the ones in bold that apply to what we're doing
Okay.
now. Okay?
Thank you.
Do y'all all realize why I list them in this funny way? I tried to explain that last time I gave this.
Yeah.
They come at you at whatever number they were on the AP exam. And so I can't really say, sometimes there's 2 37s or something. All right, so back to this. So you'll have some homework on this side of the book. All right, so how would I work this problem if I want to know where the maximums and minimums, increasing, decreasing is? There's something I'm going to show you that you've done before with inequalities called the first derivative test. It's a sign chart. It would be lovely if we lived back in the time. Well, I did live back in that time, so did you, but you weren't taking calculus at the time. Years ago, they used to just take a sign chart as justification, but now we actually have to write words. But most people still do a sign chart and then write words about their sign chart. It is great to have a sign chart in your AP booklet when you're taking the test. It doesn't mean you don't show it to anybody. We all smile when we see one when we're grading because it helps you organize your information, okay? So sight unseen, I can just take the derivative of this and I get x squared minus 2x minus 3. So I don't care what that looks like. I know what makes my first derivative equal to 0. This one will factor. If it won't factor, it probably, if you can't factor and I can't factor fast, it probably can't be factored. And just go straight to your calculator. I would not go to the quadratic formula because you'll need your calculator eventually anyway, because any calculator active question is going to have all those decimals in it. Y'all will start to see enough AP questions to realize that. So when you see a calculator active question with a bunch of decimals, don't risk any algebra mistakes. In fact, you might want to type this in y1 and take the derivative in y2, which I probably need to go over again. Maybe I'll do that in a while. All right, but anyway, this is x times x, 3 and 1 minus and plus. And so as long as these are part of the domain, which I'm always thinking about, but the domain of a polynomial is all real numbers, so I know that I'm safe on this problem. All right, so these are what we call our critical numbers. How do you show all of this on when you're doing a free response? If I ask you where something's increasing or decreasing, you show that you took the first derivative, you set it equal to 0, you now know your critical numbers. What do I mean by critical? This thing looks like that. Do you see 2 critical numbers? I mean, they're real important numbers, right? Like it's not this one. I think we all see where our critical numbers are.
Yeah.
Critical numbers occur at what makes your first derivative 0 or undefined, as long as they're part of your original problem. Okay? All right, so then I would do a plus minus chart. So always label your charts. This is a number line. I usually don't put the arrows on it, but that's really a number line, okay? You will definitely want to do this. Sometimes I'll only see it on a graph, okay? My critical numbers in numeric order are -1 and 3. Now I want to know what my first derivative is. I'm going to go over these words because we're going to go back and forth from our original to our second derivative to our first derivative. By the time you have a test on this, I might give you a picture of the second derivative and ask you to graph the original. Okay? So we got to be fluid through all of these things eventually. So I want to tell you this. What the first derivative is tells me what the original is doing. It can get confusing, but I sort of alluded to that earlier today. If my first derivative is positive, listen to the words. The original function is increasing. It tells me what it's doing. How is it behaving? Do y'all see what I mean? Yeah. Obviously, it's going to be a big deal because I'm being really adamant about that. Because people get confused. They want to say, my first derivative is increasing. Well, maybe it is, maybe it's not. I don't really care. Couldn't you have negatives that are increasing? Yeah. Y'all see what I mean? So just because your first derivative is increasing doesn't mean anything for this. It does mean something for later on, but not right now. So whenever you're taking the derivative of something, you're looking at what it actually is. Is it positive? Is it negative? Enough said. If it's negative, your function is decreasing. Are y'all okay with that? We'll say that a lot. All right, now, so I want to know what is this? What is my first derivative? You're going to have to train your brain not to look at what your derivative's doing. You want to look at what it is. I'm going to make a big deal about that in just a minute, okay? Fill it in to your first derivative wherever you see fit. You can fill it in here or here, it being the numbers I'm about to choose. These are the only places where my first derivative was 0. Therefore, it's got to have some sort of sign everywhere else. Are y'all okay with that? So I'll just pick a convenient number before -1. Okay? Rose, you want to pick a number before -1? -2. All right. What's -2 minus 3 is a negative, and -2 plus 1 is a negative. In fact, girls, many times I probably don't ever stress over finding the number. I need to know what it is, like what type of number is it. What's a negative times a negative?
Positive.
Positive. All right, so you just do whatever you have here, or you could have filled it in there. Hopefully you fill in 0 between these. And I get a negative times a positive, so it's negative in here. And then after 3, like 4, they both click over to positive. And so this tells me what my original is doing. It's increasing, decreasing, increasing. Then you can look at this to answer all the questions. It used to be you could just say things. Okay, now I know at -1, I have a relative maximum. How do I know that? Because my first derivative was 0, and my first derivative changes from positive to negative. So there's a relative or local max at x equals -1. And I know that because my first derivative is equal to 0 and changes from positive to negative at x equals -1. So you see you're looking at this and writing your sentence. Did I do it wrong?
She thinks that the writing looks 3D. Like it looks like it's
Oh.
coming off of the book. Because it's red and blue, that's why.
Are we okay with the math up here? But that sounds like something I would be stuck on the 3D look of it. Okay, now it's not going to be an absolute max in this scenario because we know about this polynomial. It goes all the way up, but we'll talk about absolute max in a few minutes. This is at least a relative min, and I would say relative min at x equals 3 because my first derivative was 0 and changed from negative to positive. You've got to tell them how you know, but you're just rewriting your little sign chart in words. Okay, Anna?
Oh, never mind, I figured it out.
You sure?
Yeah.
Okay, now I'm going to draw a graph of my first derivative. I don't know why it won't ever let me extend the page in here. All right, so what was it? X cubed. Some of y'all are taking notes. X cubed.
X cubed minus 2x minus 3.
Thank you. My zeros were at -1 and 3. That is my first derivative. On homeworks and tests, quizzes, you're going to see sometimes just the first derivative and they start asking you questions about the original. You don't even have an equation, you just got a picture. Get away from the picture as fast as you can. Okay, because your brain will start playing tricks on you. You'll start calling this a critical number down here, okay? I want to know what the first derivative is to know what my function is doing. This is a picture of my first derivative. I'm going to immediately try to train you to go straight to a first derivative chart, okay? To a sign chart. The first derivative test is what this is right here, okay? It's 0. What is it? My first derivative is 0 at -1. My first derivative is 0 at 3. What is my first derivative at back here? Doesn't it go from positive to negative to positive? I'm not looking at what it's doing. I do not care if the first derivative is decreasing or increasing. I care what my first derivative is. This is a report to you of what the slopes were. Weren't your slopes positive numbers? And then your slopes were what? All of those are negative numbers. Some are bigger than others, but that's okay. This is going positive, negative, positive. Get away from that picture. If you don't see what I mean now, you'll see it later. You'll go, oh, I'm looking at what it's doing. You're supposed to be looking at what it is. Now, what are you looking at if you're looking at the original? You wanna look at what it's doing to tell what your first derivative is. Very good. So if my original is decreasing, I know my first derivative is negative. If my first derivative is negative, I know my original is decreasing. Obviously that can get confusing. You may not feel it now, but you will sometimes. And then you make a little note to self. This is a little picture basically of my, it's a really ugly little thing. Isn't this a picture of what's happening with my original function? And I don't remember, let's see, I graphed it. The original function looked like this. Did everybody's look sort of like this?
Yeah.
Okay, why do they want you to, oh, by the way, if they actually say sketch a graph and like on a test or a quiz, you actually always need to mark off units and stuff, but they almost always provide you with an axis anyway. What's really important here is right here where my derivative was 0, do you see that? Right here where my derivative is 0, I see that. Also, during this entire time that that's decreasing, girls, during that entire time between these two lines, is my derivative negative. Okay, now why does it do that little funny loopy thing? Why is it doing something different? Because once it leaves 0, my negatives are pretty small, aren't they? Like -1/2, -1, and during here, what happens? I get -2, -4, and then what happens is I head back toward this. They're coming back up in the negatives towards 0. Do y'all see why that happens?
Yeah.
Okay, and then this part, from here on out, look at the yellow is my derivative, and the purple is my original right now. While this is positive, what is my function doing during that time? Increasing, okay? And the slopes are getting bigger and bigger and bigger. Do you see how you can look at all of that together? Okay, so that's why we were superimposing it. You see me do it with sine and cosine before, where I drew a sine graph and had you suppose what the derivative of sine was cosine. I don't know if y'all remember that or not, but we put two graphs together. You're gonna be doing that a lot, okay? So let's go on to number 2. All right, number 2, y is equal to x minus 1 to the 2/3 power. This domain I need to be aware of from the beginning is all real numbers. You want to be aware of it from the beginning. I'm going to compare it right away to this function. What if I had this function? We're going to just kind of go off on a tangent. We're going to go off-road for a minute. So y is equal to 1 over x minus 3 squared, which is x minus 3 to the -2. First derivative is going to give me -2, chain rule, x minus 3 to the -3 times 1. Is everybody okay with that? It's not on your sheet. Y prime is -2 over x minus 3 cubed. Super cool things happen here. Doesn't it appear right now our critical number could be at 3? Because it makes the bottom 0. You look at what makes the top 0 or the bottom 0. If the top is 0, it's leveled off. If the bottom's 0, you have a vertical tangent. Okay? Not on this problem though. It's really hard for me to call a critical number something that's not even there. Like if, we were having student body elections and somebody wanted to run for president that goes to Sacred Heart, we couldn't vote for them. You don't even go here. Okay? 3 doesn't go here. 3 does not belong in this graph. It can't be critical if it's not there. That make sense? Okay? I can't say the highest grade on the last test was somebody that goes to another school. They didn't even take the test. They're not even here. Okay? Are y'all alright with that?
Yeah.
You need to still include it though in your chart. Do not call it anything. If you've accidentally done it, go back and cross it out. And I'm not talking algebraically where you were probably trained, and I've taught some of you, to go back and check your answers and make sure you didn't have extraneous roots. That's not what I'm talking about. I'm talking about be aware of your domain from the beginning. Alright? So I'm aware that 3 cannot be part of this. I might even note to self, underline it or something so I won't get lazy about it or be careless. Alright, however, I would put it in my plus minus chart. I would put 3. I had a suggestion from a student years ago to cross it out so you won't call it anything. But 3 is still important. Don't you? It looks like an important part of this. Alright? So let's pick a number before 3, like 1. The top is negative, and the bottom is going to be negative, isn't it? So it's positive before. And then if I pick a number after 1, I get a negative over a positive. A number after what? 3, like 4. Now the bottom flips over to positive, and I have a negative. So that is my derivative. It tells me my original is increasing and then decreasing. Why can I not say 3 isn't even the absolute max? By the way, let me pause there. If you know for sure a function, all it ever does is increase and then decrease, as long as it's defined there, doesn't that have to be the absolute maximum if it never goes back up again? But why can I call 3 maximum? It's not even there. There's a what there? Vertical asymptote. Okay, so this original graph, y, has an asymptote Morgan at 3, and it looks like this. What is it doing before 3? Where my first derivative is positive, isn't it increasing? What is it doing after 3? Decreasing. So, I'm sorry, it's getting to be a mess on top of their faces. Let me move these sweet girls. Okay. I definitely want to still look at my first derivative with the point in play where it's undefined. So I think we'd all agree that I still want to know what's going on around something undefined. That's always been important. Okay, so let's pause for a minute. I definitely want to look and see where the first derivative is undefined. You can't call it any, but you can't actually call that number anything if it's not part of your domain. And we're going to go back to this other graph. But do y'all see there's no relative extrema here? I'm sorry, that's the word, extrema, you'll see. It means extremes, like maxes and mins. Is there any minimum here? No. Is there any maximum? No. Okay. So just big deal, don't make the mistake of calling something if it's not even there, but please put it in your chart. I think it's a good idea to cross it out though from the get-go so you know that you want to talk about, let me say this real quickly. Do y'all see I would like this if somebody asked me where it's increasing? I'm glad I did that. It's increasing from negative infinity to 3. It's decreasing from 3 to infinity. Now's the time to have the discussion about do you include the 3 or not? And this for sure not. I would say it's increasing from negative infinity to 3. And then a lot of times we'll do union. I'm sorry, that one's only increasing in one place. They don't care if you use interval notation or write it out in words or use the little alligator thing. They don't care, the little less than or greater than, okay? You will see some books. I can't remember if ours does on Count Chat or Slater. You'll see in some books where on some graphs like this one, they would say that this graph is increasing or let's use decreasing because it's only at one time. They would say it's decreasing right in here from -1 to 3, and you'll see brackets around those. There are some people that if the number is part of the problem, they will include it. It seems almost crazy. Here's the safety net that I want to move on past real fast, then I'll come back and talk about it. It doesn't matter whether you include it or not to us as AP readers, so just don't include it, except for in one situation I'll show you, okay? So, we don't care if you include the number or not, so it's safer not to, just in case you made a mistake and included something that wasn't in your domain. Why in the world would some people include it though? Isn't that kind of confusing? Like here's the graph, increasing, decreasing, increasing. The argument that a lot of people have is that -1, it's not doing either one. It just finished increasing and it's about to start decreasing. So why in the world would I include -1? There are very intelligent people that would include -1, and their reasoning is this. During this time, the slopes are negative, and during that time, it is decreasing if you look at only that piece alone. If you didn't know the other pieces were there, and that's the only thing you have is the yellow piece, it's decreasing from -1 to 3. You can just leave out the brackets, though. Just put it in parentheses and we'll be safe, okay? Here, the bracket people, in this problem, do you see there's no way I'm going to include the 3 in anything? Anything that I say about this, I better not include 3, okay? I guess the caveat to that is a graph like this that is occasionally, it's not a big deal, it's not going to make or break your score on the exam or my grade in here. But if a graph stopped and had endpoints, without an arrow, and you knew that this graph was only from -3 to 4, then I would say it's increasing from 0 to 4, and y'all see it? Y'all see the difference there? At 4, it still is increasing. Okay. That doesn't happen often, it's not going to kill you, all right? So don't get caught up in that. All right, back to this one. Didn't I do that on the other side? I already took the derivative of that. Or did I? No, haven't done this one. Okay, is 1 part of this graph? In algebra class, I used to call that my most important number. I evaded calling it the critical number because I know that's coming later. So critical is a little more important than important, all right? Like a critical care unit in a hospital, that's like, you know, they're really on their game there. 1 is defined. 0 to the 2/3 power is 0. 1 is defined, okay? So now I'm going to take the derivative, and I have 2/3 times x minus 1 to the -1/3 times 1 using the chain rule. So my first derivative is 2 over 3 times x minus 1 to the 1/3. I have a critical number where my first derivative is either 0 or undefined. So I have a critical number at 1. A note to self, yeah, 1 does exist there. It is continuous. Now what do I know about it from my first derivative chart? My only critical number is 1. To reiterate, if it wasn't defined here, but it shows up here, I still include it in my chart. They still needs to be there because things happen around it, but you would exit out. Should I keep going? Okay. All right, before 1, like 0, if you put in 0 here, you'll have a -1 to an odd power. So isn't that going to be a positive over a negative? Okay, just go slowly through that. After 1, if you put in any number after 1, that's going to click over to a positive. Oh, I know, there's been something swimming around in my head every time I do one of these charts that I want to tell you. It does not have to go positive, negative, negative. You will see something go positive, positive, negative, so don't get caught up in the alternating thing, okay? Graphs can do all sorts of things. All right, so what does that tell me about my original? What this is tells me my original is decreasing and then increasing. There is not only a local min at 1, how do I know it's an absolute min? There's no other behavior on this graph. My calculus will show me every shred of hidden behavior. Something that I couldn't see on my screen, it'll show me. My watch is ringing. So anyway, this graph looked like this. At 1, it was decreasing and then increasing. And this does show me I have a relative minimum. Okay, the graph of the derivative, interestingly enough, looked like this. It had an asymptote at 1, and it was one of these rational function graphs, sort of like this. Okay? Now, why did they have you do that, other than it's just aggravating? While this is negative, this one is decreasing. Also, these slopes are getting more and more negative, aren't they? This is a report of what the slope was at that moment. Look at this report. Do y'all see what I mean? Okay? And over here, this is a report of what your slope is at that moment. Early on, aren't your slopes high? Big numbers. And then they start to level off just so you can see how those all go together. And you see your first derivative is undefined at 1, which is a big flag, okay? Like, look at me, all right? Let's go on and do number 3. Okay, number 3, I immediately wrote this like this. You don't want to deal with absolute value in this class or in any class. I would argue with you, you've never dealt with absolute value. First moment that you saw it in middle school, your teacher probably broke it up into 2 pieces. Sometimes they can break up into more than 2 pieces. It depends on what's in there, okay? This is just a line. What's it going to do to the positive part of the line? Nothing. Absolutely nothing. What's it going to do to the negative part of the line? It's going to totally change it. The part that's hanging below the graph is going to pop up above the graph. Okay? My most important number here again is 1. 1, 0 is where everything happens. It's not a critical number yet. Okay? So I'm going to take the first derivative. Oh, I'm sorry. I'm going to write it like this. It's x minus 1 if x is greater than 1, and it's negative x plus 1 if x is less than 1. I don't care where you include the 1, but just include it if it's part of the domain. Okay? I would just break it up into piecewise and then go for it. So take my advice. I'm always trying to make your life easier. You may want to fight that, but how in the world are you going to take a derivative of absolute value? I don't know. Y'all see? You're also not going to be able to take an integral, if you know what that is, of absolute value. You also couldn't do algebra with absolute value. We've always broken it up and said, what about this, what about that? What's going to happen here while I'm thinking about it? How would I rewrite that? Absolute value is not doing anything to that graph, is it? Okay? Think of the picture. This helped me tons in my calculus. When I started to, just see how often I'm slapping pictures in front of your face. Because if you can see it, you can understand it. We know from our algebra that it's like this, right? So I absolute value picture sometimes. It's not going to do anything to that. The picture of x minus 1 looks like this. If I absolute value that picture, the positives are going to stay, and these are going to completely change their signs. Okay? So what if you have one like this? What are your most important numbers here?
I like this one. It's like
It is. What's it like, Morgan?
like this.
It makes a W instead of a V, okay? It comes down to -3, hops up, and then goes. I'm glad you knew that, okay? The reason for that is what does x squared minus 9 look like? X squared minus 9 looks like this. So what is it gonna do to the positives? And the negatives is gonna do this. Okay. Now that I've gone that far, I didn't even have that in my lesson today, but I've got to make sure that I say this at some point. If Morgan and I type into our calculator the absolute value of x squared minus 9, we probably won't get the right picture. We might, but it does a poor job of graphing absolute value, so always know that, okay? The reason is it's counting by pixels and it's lighting things up by about 0.212, okay? That's what it's counting by. It's not counting by integers. So many times it's the last point it found is like one like this, and the next point it finds is one like that, and so it can give you a picture in connected mode that's wrong.
Can you
So
change?
you need to know what you're doing, okay? Here's what I suggest. Don't ever put absolute value in your calculator. Type in the function inside and do what I do, absolute value of the picture. Okay? like this, if I had the absolute value of some horrible thing, okay, or it could be a simple thing, I'm not going to put absolute value around it because the calculators don't do a good job of graphing it. Desmos does a pretty good job, but that's neither here nor there. If I look at the function, I know for sure where the zeros are. I can find those with calc 0 if I need to. And if I absolute value this picture, that's unaffected and that's unaffected, and these two parts flip up like the Loch Ness Monster, I guess. Okay? Absolute value the picture. I'm so glad all of these people are sitting in the room because I am going so fast, but y'all are like clear faced, you're like, okay. Of course, I'll reiterate this on an ongoing basis. All right, now, so back to number 3. So you have f of x is equal to the absolute value of x minus 1. Sorry, I'm going to rewrite it like I had on the other page. Always, do you see how important it is to label now? Because you're going to have first and second derivatives going on at the same time. So I'm going to write this as x minus 1 when x is greater than or equal to 1, and its total opposite when x is less than 1. If it's positive, you can just drop the bars. If it's negative, you could drop the bars but change all the signs. All right, so my first derivative, now I can take, I put one like this, I think, on the test actually. The first derivative of x minus 1 is 1. The first derivative of that is negative 1. What will I write here? I think you've only seen me do this in video. I did not include the 1. When you're taking a derivative, hold off on including any numbers until you're sure that it's really part of the derivative. Why can I not include 1 in my statement here? The derivative has to be the same from what? It has to be the same from the left and the right to be differentiable. Okay? So what I have here on the absolute value of x minus 1, okay, the slope of this line is 1. The slope of this line is negative 1. Do you see how that makes perfect sense? While my derivative is negative, is my function decreasing at that constant rate? And more than that, I really care when my derivative is undefined. 1 is part of this graph, but the derivative is undefined right there, and it'll show me a critical number. That's also a absolute minimum also, okay? All right, now we're gonna work real quickly this problem from the first slide or two. Oh, it was one I typed in my calculator. All right, 2x minus 1, 3x minus 1, and x. Remember, if all we did was just graph it in a standard viewing window, how would we even know how to change our window? How would we even know anything's there? All right, so I'm going to multiply this out. And you would see it just as an x cubed graph. You would not have it in this form most likely given to you. That would be a luxury. If it is, don't multiply it out. Just use it as is. And you might want to multiply it out so you don't have to do a triple product rule. But anyway, this is 2x squared minus x. I'll make sure I don't make a mistake. Times 3x minus 1. So that's 6x cubed minus 2x squared minus 3x squared. I don't know where I am. Minus x. All right, so looking back at the calculator, how can I check and make sure I've got it right? Let's put it into y2. So what did I have? 6x cubed. What else? Minus 5x squared plus x. Okay, I'm going to go to table because I don't want to wait on it to graph, and it looks like I got the right thing. Look what they're saying. While I'm on the calculator, the way to take a derivative on your calculator, okay, is you can go to math, I need to look at it up here. Math 8, in terms of x, you want to call up the variable. Right now, the one I want to take the derivative of is in y1. And you want to do it for every x. And you can't get like an algebra equation, but you can see the result, which I'm going to keep going. All right, so up here, I'm going to turn off the original for a minute, and I'm only going to look at the derivative. Oh, I'm a little suspicious as to what's happening there, right? Okay, so if I get my derivative over here, if this is calculator active, I might then see I need to expand my window and find my zeros. A great thing they do sometimes, they don't use super stressing over your window. You'll notice them giving you a window many times, okay? But y'all see that if this is my first derivative, it goes positive, negative, positive. So I can get a whole lot out of that picture. Could I do calc 0 to find my critical numbers? On your test, don't say I went to second calc 0 or write that notation, math 8, y1. Do not write that, okay? Tell them that you took the first derivative and it equals 0 when x is 0.5 and x is 0.3 repeating, okay? Don't use calculator terminology, use calculus terminology. Then they know you know what you're doing. All right, now to speed on through this problem, do you see that from my first derivative, how will we know about the hidden behavior? From the first derivative, I get 18x squared minus 10x minus 1. And that can be factored. Unless I did something wrong. That should be able to factor into 1/2 and 1/3. I don't see how that's going to do that. Did I make any mistakes? That's not going to be bad, is it? So I feel like I did something wrong somewhere. 6x cubed. Oh, those are the zeros. Those aren't the critical numbers, sorry. And we'll pick up on this one next class, and I'll go back and make sure I don't make a mistake. But I want to say this, okay? I'm sorry. What I started thinking about was where the original function is 0. So just pause for a minute as you're packing up. Pause your brain, but pack up. What I really meant to be doing right now is where my first derivative is 0, which we still didn't know yet. Do y'all see what I mean? The point of this is, I knew for my first derivative that it was positive, negative, positive. Therefore, no matter what I see on my calculator, I'm smart enough to know it's increasing, decreasing, increasing, whether I see it on my screen or not. All right?
Thank you.
All right, bye.